Yeah, thanks a lot for joining me today. I'm really flattered that so many of you came here to listen to me. So, yeah, let's start. The topic today is architecture components, and the title also includes Kotlin. I guess it was more like a disclaimer. I'm using Kotlin for a long time now, and you really cannot expect me to write a single line of Java anymore. So that's why all our code examples today will be in Kotlin, but I guess it won't be a problem because we saw a lot of Kotlin already on this conference. Who am I? I think I was already properly introduced. It's another talk about Android architecture, and we had a lot of these already on this droidCon, so it seems to be a very important issue to us. And why is that? Because I guess you can agree that we all want to write high quality code that is maintainable, that is clean, that is readable, and the architecture, of course, is the basis to all of that. So let's start off with a little question. How do you actually measure high quality code? Anyone? Okay, so like code reviews, and if your colleague says it's good, yeah. You might think of static code analysis maybe, but I think the only real measurement of high quality code is this. It's WTFs per minute. So when I started developing Android, there was an Android project and I never did Android, and I thought, how can I get into it? So I looked up some sources and I ended up with a book. And after I read it, I just dived into it and tried to apply some MVC-ish pattern that I took away from my previous projects. And in the end, I ended up with something that had very huge activities. So like MVC is like put everything in the activity, and my actual architecture maybe looked something like this. So I was looking in options how to improve it, and again I came up with some libraries. There are a lot of libraries, and they were there for a long time, that do some code generation, reduce your boilerplate code, make your life easier. So in the end I maybe came up with something that looked like this. It was still not ideal, but at least the direction was clear. And finally, I tried an MVP approach, which was probably the first architecture that was for the Android platform, and it already worked quite well. So you can really work well with it, and I think a lot of people of you still work with MVP, but I think it still has its rough edges. So what I ended up eventually is MVVM, and currently I'm feeling quite comfortable with that. But it took me a long time to go through all these iterations. It were some years, and all the while what Google had to say about how an Android app architecture should look like was this. Until this year's Google I/O. So in this year's Google I/O, they finally released a guide on how an Android architecture should look like. So let's look at it quickly, what Google suggests. So you still have your activity and fragment as a kind of root of all evil, you would say. And they say you should you should keep it as lean as possible. So you still need it to create your view, to wire up your components, but you shouldn't really do any business logic there if possible. Instead, of course, you also create your view here, and your view is there to be filled with data, right? But you shouldn't use the activity or fragment to fetch this data, but instead you should feed your view from a view model, and Yeah, it's there, as I said, for the view to pull the data out of the view model and also to push events to the view model that again changes the data. And the view model, you don't want to put too much code in the view model as well, of course. So normally you would have several data sources, and what you should do is use a repository pattern to just act as a kind of a mediator between your data sources, which in the end might be a web service, your SQLite database, or even an in-memory cache. Yeah, and in most of the cases you might have all three of those, so you really need some layer that abstracts this away from the view model. Yes, so if we look at this, I mean, this is basically just an MVVM, so it's really nothing new to us. But it wasn't the only thing Google released in this year's I/O, but they also introduced architecture components. So this is a set. There are of small APIs, libraries, and they help you to circumvent certain difficulties in Android architecture. One of those is Room. I won't cover Room in this talk. We already had a great talk yesterday about it, I think. And it's also way off in the data layer, so I will concentrate on the other three instead. Yes, let's start with the view model. So to understand the target of the view model, I would just have a quick look at an activity lifecycle. So what normally, what all of our applications do, we have an activity, and you create this activity, and eventually you get a configuration change, like your user will rotate the device. So what happens now is your activity is destroyed, so you run through on pause, on stop, on destroy, and a new instance of an activity is created. And now it starts all over again, so we run again through on create, on start, and on resume. And eventually the user will finish the activity, so maybe exit your application or whatever, and you run through the destruction again, and your activity is gone for good. So when we used MVVM approach before, our view model had the same lifetime as our activity instance. And this has some issues, of course, which you might all know. So when the activity is recreated and your view model is recreated, you have to save your state before the destruction, you have to restore your state after the destruction. You might have long-running tasks that are not finished yet. And if the view model is recreated, you might have to restart these tasks, which you really don't want to do because you don't want to lose the time you already spent there. And what the activity components view model does for us is that their life cycle is extended to the whole life of the activity until it is finally destroyed. And how it is achieved in the background, it's just a fragment with retain instance state set to true. So it will actually survive all the configuration changes, and it will be destroyed with the activity when it's finished. Okay, so let's just, I prepared some code snippets. Let's just look at what it is. So I have a very highly innovative app here, which is one that triggers the GitHub API. I guess you will never have seen such a sample before. And when I type when I type something, then it's searching for a GitHub user, basically. Okay. that's it for the demo, just so you know what we are talking about. So let's just quickly start off with the activity. What the activity does, we just have this GitHub activity, and first we start off by instantiating an injector. A dependency injection for me is a really important thing. You should definitely always have some dependency injection solution in place to put your instances together. What Google suggests you should use is Dagger 2. I think most of you are familiar with that. In my example, I will give you the GitHub link later. I use Kotlin, which is a nice little dependency injection framework for Kotlin exclusively. So I guess you can also use it from Java, but you don't get you get the most benefit of it if it's in Kotlin. And the difference between the two is that that Dagger works with a lot of magic, a lot of generated code, while Kotlin is a bit more straightforward. So the disadvantage is that you will have to create providers for each class you want to provide through Kotlin, but the advantage is that it's really streamlined and there's no magic involved. You always know what's going on. So I like using it. I must confess, I didn't use it on a large-scale project yet, but on small to medium-scale projects, it worked out quite nicely. So now we have our injector in place. We can let it inject our dependencies. So I have an adapter here for the recycler view and some input method manager to hide the keyboard. And I'm injecting those I'm using lazy initialization here. So the problem with an activity, we all know, is you cannot just initialize everything in the constructor right away, but the activity has to be at least in the initialized state so you can get views and stuff like that. So the lazy initialization of Kotlin can help you here. You could still define or do your assignment in the constructor, but the advantage is that it's only initialized the first time you use it. So when you use it the first time in onCreate, it's also only initialized in onCreate, but you keep your onCreate clean because you don't have to put all your initialization code there. So next is our views. And as a little side note, with the last support library, which is still in beta, it seems like they made the nasty find view by ID at least generic, so you don't have to do this nasty cast anymore. And there are our other views, and now we can look at our onCreate. It's so far it's not doing much interesting stuff. We just set our content view, we initialize the recycler view. And now we're ready to create our view model. To create a view model, we need a view model provider, and we can get this by view model providers auth. And the argument here is a lifecycle owner. Lifecycle owner is just an interface which has one method, and this is get lifecycle to retrieve the current lifecycle. And it's implemented by the lifecycle activity. This is a temporary solution. So as soon as the activity components hit version 1.0, they will integrate it into the normal activities. So like, I guess they will start with the app compat activity, and maybe with the next version of Android, they will also incorporate it in the activity itself. So far, so good. And optional, you can use this this view model provider if you have only view model. If you want to instantiate a view model that has no arguments constructor. If you need to control the constructor, then you can add a view model factory. So another advantage of the view model factory is that if you don't have it in place, then your instance will be created via reflection. And this is especially slow for new instance creation, so you might want to use this view model factory anyways, although I still think it's okay in this case if you only instantiate one view model and you do it while the whole activity is constructed anyways, which is a time-consuming thing anyways, so I guess you won't realize the difference, but I would still suggest to always use these factories. So how does this factory look like? For the factory, we again have to implement an interface that has only one method, which is create. And it takes a class and expects as a return value an instance of that class. So that's pretty easy. I just check what the class is, and then I create my view model through my injector again. And otherwise, I throw an exception. So to put it together, we have our view model provider, and we can now get an instance of our view model through its class. So let's look into the view model. First, we can, of course, now use the view model. So if we add a click listener, for example, on the little search view you saw before, then we essentially we trigger search users on the view model and expect our data back at some point. So now let's look into the view model. I'm afraid I have to repeat myself. So you have to implement view model, which is an abstract class in this case, and it has exactly one function, which is onCleared. So onCleared is called only once before your view model is destroyed. And it's actually not called when your activity is destroyed because of a configuration change, but only finally in the end when your activity is really finished and finally destroyed. So this would be the way to clean up all the dependencies you have that might keep this instance from being garbage collected. So, for example, if you use Rx, this would be the place to get rid of your disposables. And of course, since we control the constructor, we can have a nice constructor injection for our dependencies. And we can now implement our search users method. And yeah, what we do is basically trigger the search at the repository. And now we receive the data, and we can have a look at how to bring this data back to the view. And that's what live data is for. So live data is an implementation of the observable pattern. And yeah, basically you can continuously push values there, and you can observe the live data for changes. It's basically the same as a published subject in Rx. So it's a long-living thing. You can continually push new values, and on the observing side, you get those values. And when you first observe the live data, you get the last value back if there is one. So let's look at it, how we can integrate these into our view model. We have these mutable live data here, so we can actually change it. And we have two, ones for the list of GitHub users we get back from the web service, and one for showing progress or not. And now we can change these values as we want. There are actually two ways to change these values. The first one is just the set value, and Kotlin the Kotlin compiler just transfers this to the property access internally. So what behind this is actually a set value function. When you use set value, then you have to make sure yourself that you're on the right thread. So basically this is for updating your views, and of course you have to be on the view thread. We're doing this here in our Rx code by switching to the main thread before we call the onNext. But there's an alternative. So there's a second function between set value, which is post value. And post value will ensure that this runs on the main thread. So you can just choose whatever is best for your use case. And the nice thing about post value is if you trigger it several times before the main thread hits, it only invokes the observer once with the last value. Okay, so now we're ready to go back to our activity and subscribe to it. This is fairly straightforward, so we just subscribe to users and say observe. And observe takes two arguments. The first one is a lifecycle owner again, and you pass the lifecycle there, so the live data is can actually react to lifecycle events. So live data is lifecycle aware, how Google calls it, and when your activity is destroyed, live data will automatically remove your callback. So you don't have to care about removing the callback yourself, you don't leak. It works fine out of the box. Yeah, the lifecycle owner interface again. And the second argument is an observer, and it's again an interface with only one function, the onChanged, and you get the value. So what's not so nice for me as a Kotlin developer is that the value is nullable. So I have to work around that because I almost never have nullable types in my apps anymore. That's a little downside for me, but the rest is pretty straightforward. And of course we have the same thing for show progress. So now our activity is done, but there's already a small thing that I want to point my finger on. So we already produced some boilerplate. And imagine if you have 5, 4, or 6 values you want to observe, it gets pretty messy pretty quickly. So I would suggest to always have to use a more single source of truthish approach here, and always have one data class that accumulates all the data you want to pass, and just use this one thing. Okay. Are you still with me? Because I have one more. So let's talk about lifecycle handling. That's the third component I want to talk about today. And yeah, what does it do? Before we answer that question, let's just have a quick look at our lifecycle again. And the Android lifecycle is composed of 2 components, which is states and transitions. So you have states and transitions that will lead to the next state. So with our activity, we first start with initialized, and then our onCreate is called, and onCreate transitions this our activity to the created state. And then we have onStart, and we end up in onStarted. With onResume, we end up in resumed, and then we go backwards again. With onPause, we are back to started. So we are not paused, but in the state started again. And onStop leads us back to created, and with onDestroy, after onDestroy, we end up in destroyed. So yeah, when we create Android apps, we of course we want to focus on separation of concerns. And since the lifecycle is such a big thing in Android, we just need a tool to distribute these lifecycle events to other components than the activity. And some of you might already have a mechanism like this in place. We certainly do. So we have we written some constructs ourselves where you can just attach some lifecycle event handlers to one delegate, and so you get all your events and can handle your stuff, the stuff yourself. And this is what the lifecycle handling is in the architecture components is for as well. So it enables you to make your components other than the activity lifecycle aware, which which you can use to reach a better separation of concerns. So what? Yeah, one other thing you could imagine would be nice in the future. There are a lot of libraries, like tracking libraries and stuff. We all love them. And they always want to have on start and on stop delegated to them. So you could imagine they could just handle their life cycles themselves in the future and would be much nicer for us. Right now, our activity taken all together looks like this. And as I said in the very beginning, my first approach to Android ended up in huge more than 1,000 lines of code-ish activities, which were really, really nasty. So right now I'm trying to keep really all the code out of my activities. And that's our activity right now. It doesn't look so bad, right? But how if it could look like this? I like this much better. Because activities, you don't own them, you don't instantiate them, you cannot really unit test them, and I would like to have my code unit tested. So what I did here is I extracted the GitHub View class, and this GitHub View class is a lifecycle aware class, and I'm doing everything there. I still have to create the view, of course, in the activity, and I have to set this view to my view class, and finally I have to register my view as an observable to my lifecycle activities lifecycle. So how does this one look like? Yeah, we have our GitHub view, and it implements the lifecycle observer interface. This lifecycle observer interface is just for adding your view to the as an observer. So it's a pure marker interface. It doesn't have any functions or something. But yeah. So the first thing I like about this approach is you get rid of this injector here. So you only use the injector once to create this whole view, and all the other stuff, the injector is out of business and is doing this automatically. So you have some nice constructor injection again for all your dependencies. You have to set the root view because you pull all your views out of this one. And in this case, we're doing it like that. So I just created a little helper function to get rid of some boilerplate code here. And yeah, we can come to the interesting part, which is how you handle lifecycle events here. So you can annotate any public function in this class with the add on lifecycle event annotation. And this takes one parameter, which states which transition you want to handle here, which event you want to handle here. In this case, it's onCreate. The function's name is onCreate, but it can be any name. And it must not have any parameter. So in fact, there are two options. One is the zero parameter function, and optionally you can have the lifecycle owner as a parameter. So you can access the lifecycle from there again. And we will also need it in this second. But what it's also good for, as I said, there's the distinction between states and transitions into states. So the lifecycle enables you to check what the current state is actually. And you can either check directly, like here, if it's started, or you can say if it's at least created. So this would be true for created, of course, but also for started and resumed. But back to our example. So we're initializing the recycler view again. We're setting our onClick listener, and we register our register to the live data from the view model. So that's quite the same code from the activity, just that it's not in the activity, and we need the lifecycle owner here again. As mentioned, you can just reach it into that function. So what can we do as well? We can have several functions for the same transition. So in this case, I just separated everything out again. So I have one function for the init recycler view, one to init the search view, and one to start observing thing. I like this quite a lot. But you can decide for yourself. What you cannot do is have one function receiving several events. So the on-lifecycle event annotation is exclusive for a function, and you can only have one parameter there. So now we talked a lot about MVVM. I think a lot of people still using MVP. Who's using MVP? Okay, as I said, a lot. How can you use these architecture components in MVP? I think you're kind of out of luck concerning the view model and the live data. Because the live data, it's pretty obvious because it's just another approach. You pull the data out of the view model, and with MVP you push the data into the view via an interface. And that's also the reason why the view model thing is not really working. I mean, you could think of just having your presenter implement view model to make it live longer, but then you still have this dependency on the view, and although you hide it behind the interface, it's still there. So you would still have to somehow get rid of this reference when the activity is destroyed after an orientation change. What you definitely can use is the lifecycle awareness, of course. So just use it to move your code, to separate your code into smaller pieces and let components handle their own life cycles. And there's another point. So we personally are using data binding. So how does this work with data binding? It turns out, gave me kind of a hard time thinking about it, how I implement these, how I get these live data into my XML in the end, which is kind of nasty because you need the life cycle to observe. You need this life cycle to observe the live data and enable the live data to get rid of the callbacks on the destruction of the activities, right? So there's also this observe forever function that doesn't take a life cycle, but as the function name also says, it observes forever. So you have to take care of detaching your listeners yourself, so you didn't win anything. But it turns out that you can just use observable fields in your view model, because of course, you have the same problem there, right? You have these callbacks, and your view is observing your observable fields via callbacks, and you have to clean it up. But it turns out that you don't have to, because they are weak references. So you can just use the view model with observable fields as well. Apart from that, the problem is that live data is still in beta, and when it will reach 1.0, the data binding team will also make the data binding lifecycle aware somehow. They didn't have any details on that yet, but it will come. But if you want to use it now, I would suggest to just use observable fields. Yeah, just to sum it up a bit, as I mentioned it already, lifecycle components are still in beta. It feels quite stable to me, and it's nice to play around with it. I used it in smaller projects and didn't have any problems with it. But of course, the devil is always in the details. So if you have a bigger project, you will maybe run into issues. So you will probably want to wait until it's stable. But I can definitely recommend playing around with it if you're interested. The good thing about these architecture components is that they are designed to work on their own. So you don't have take the whole package, but you can just pick what suits your use case best. So maybe you will just use Room because it's a very nice ORM, or maybe you will just use these lifecycle awareness to improve your code, and probably you can also take the whole package, just whatever floats your boat. Yeah. And I guess that's it from me. Do we have time for questions?
Yeah. So thanks to Hendrik Kokocinski. If you have any questions, please, it's difficult. I can approach you the microphone, or if you can grab it. Thank you.
Hi. So first of all, thank you for the talk. I think that you covered in a pretty crystal way the topic, so really thank you for the awesome talk. I was curious about how did you handle the temporary displaying of views like Toast using the live data? Because we had these issues, like you use the live data to display also a temporary status like a toast, then you rotate the screen and your status is clearly that you are displaying a toast. So I know that Google pushed an example using the single live data thingy, but I didn't like it at all, so I'm curious.
I didn't think about it yet, I must confess. So I was playing with errors, so like having an error resource ID or whatever in your state, and just showing a snack bar if you receive this one. But yeah, after the orientation change, you have to clear it somehow. So yeah, I don't have a solution for that, unfortunately.
Okay, thank you.
I think.
Yeah, I just wanted to give a warning. I saw this lazy and then by lazy, and then referencing something in the view, in the layout. It gets complicated or tricky if you use it in a fragment. I already did this, and then you have the reference to the view. Then the fragment is not recreated, but the view is recreated, and then on orientation change, for example, and then yeah, you bind to the old view. Yeah.
Thanks.
I have a question concerning how you save the instance state. If you have the view model, then the view model holds all the state for the view. And if your activity exists because of a rotation change or something else, then you should have to save in this moment, but your view model lives longer. And problem is, if your app goes to the background and stays there, your view model didn't have the chance to save the state, and then it gets, for example, killed by the operating system, but the activity is not killed for being finished. It will get back if the user gets it back, and yeah.
Yeah, there's certainly several approaches to that. So for one, you could like always change your stuff when it save your data when it changes. But I mean, in the end, you still get the uncleared function call when your activity is destroyed for good. So you can change your data there as well. Okay. One last question, maybe?
Hey, so you said that you can annotate more than one method with the same on lifecycle event. So you had an example where you had 3 methods listening to onCreate. Is there any special ordering in which those methods happen, or is it just random?
It's kind of random, so you cannot really rely on the order in this case. And if you need this to run in a certain order, you have to do it in one function. Okay, thanks a lot. And
Yeah, thanks a lot to our speaker.